So the final slide of this presentation, I'd like to discuss one last thing, which is whether or not our rotational quantities are scalars or vectors. So we know two things about a vector. We know from our very first topic that a vector must have a magnitude and a direction. And we also know from that topic that when we do vector addition, it doesn't matter which order we add those vectors in. And these are the two rules that quantities must obey to be considered vectors. So with that in mind, when we look at our translational and our rotational quantities, in our translational quantity, we know our position is a scalar and our displacement, velocity, and acceleration are vectors. In our rotational quantities, we have a small difference. So our angular position is a scalar and our angular velocity and acceleration are vectors, but our angular displacement is not a vector. And the reason for this is, although our angular displacement will have a magnitude and direction, it will not obey the rule of vector addition. So for angular displacement, our result depends on the order that we add. I won't go into detail here, but I will refer you back to your textbook on page 265, figure 10.7, and the text directly next to it provide a very good description and explanation as to why angular displacement is a scalar. So for our angular velocity and acceleration, we know they're vectors. That means they have magnitude and direction. The magnitude, we saw the formulas to find that on the previous page. And so now all we need to do, and the very last thing for this video, is to find out how we find the direction for these two vectors. One of the other differences between the rotational motion and translational motion is how we define the vector direction. So in rotation, the vector direction defines the axis of rotation and not the direction of movement. So to find the vector direction, we use the right hand rule. We curl the four fingers of our right hand to point in the direction of rotation, so clockwise or anti-clockwise, and the thumb will point in the direction of the angular velocity of it or acceleration. So for example, if we have a flat disk rotating anti-clockwise, then the direction of the angular velocity should be upwards. And the very final point is, for us, in this topic, in the work that we do, we don't need to use the right hand rule. All we will need to know is that for us, we will call counterclockwise motion positive and clockwise motion negative. And that seems a little counterintuitive until you do the right hand rule. So when you do the right hand rule, if we take upwards as positive, when our thumb is pointing upwards, we have counterclockwise rotation. And congratulations, you've made it through the first video of rotation and torque.